Hi, everyone. Good morning. I'm like a minute or two. I'm so sorry. Hi, good morning, everyone. Good morning, Saja. Good morning, Amir. Hi, Daniela. Good morning. I was rushing. I don't know. Yeah. Good morning. Hi, Brad. Hi, Owen. Good morning, Jonathan. Um, I had the news on in the background, and I think I got caught up in a story, and then yeah, then I look at the time, and I'm like, oh, I'm supposed to be here. So I'm just gonna in the background pull up some documents that I need. But in the meantime, it's our last day, and good morning, Andrea and Robin. I think I said good morning to Owen too. Hello. So it's our last day, so this is a good time to ask any questions you have, or
We're not
yeah,
having class tomorrow before the test?
no, no, you just
Not even by request?
no. Normally on the day you have a final, you have the final, and that's it. So on Zoom, you have your online exam. Um, so yeah. Okay, so before I just start anything, I had like a few things I wanted to just ask you guys, and get some opinion on, really. So, good morning, everyone, again. Good morning, Bafar and Sanjita. Hello. I'm going to put in the link again to the Google form, and then I'm going to click on it just to show you guys. And this is if you are not able to enroll in Physics 102 because it's full. Although yesterday, you people hop on it, um, a spot opened up.
Yeah. I swapped it out.
Oh, yeah, that's right, Randy. We talked about it. Well, thanks, Randy, for being.
I made sure to, use that swap feature on whatchamacallit, because sometimes if you drop the class and hope you're going to get into the next class, it doesn't work that way.
Mm.
So like it's good to use the swap feature.
I didn't know there was a swap feature, so that's really, really helpful. Oh, okay. Brad said he learned the hard way too. So, um, yeah, that's good, Randy, and I'm glad you did it. And it worked.
Labor studies.
Yeah. Yeah. And so again, if you click on the link, this is only for anyone that is not officially enrolled in the class, and you want to enroll. It's so many of you that I can't keep up with the emails, and so um, with this form, you click on it. All you do is type in your name, you type in your student ID, your email, and that's it. After that, I will look at the responses and listen carefully. On Monday, I will send out an email with the Zoom link to join class on Tuesday. And then on Tuesday, I will give you the ad code on the first day of class. Um, yeah, I think we should be okay. So yeah, so guys, make sure you have your spring classes ready. Yeah, Owen. um yeah, so Owen says, I wish I could take Physics 102. I am going to offer Physics 102 in the second summer session. So second summer session, there's usually no science classes offered, not very many, maybe a chemistry or something. So Owen, if you join us, you might see some people from this class in the spring also too. Yeah, it's a good way to get it done, and come fall you'll be ready for Physics 103, and so you're caught up, right? Or you're on track still. So a really good way to continue staying on track is taking these summer courses. um, I've taught Physics 103 in the past. That's actually my where my expertise in physics actually lies, is in Physics 103. But at the moment, no, that's not my course. It's Dr. Moreno is the chair of our department, and he teaches it. And it's also, it's also taught at the other colleges. So ask around and see, whose teaching style might fit yours, right? Might fit your learning style. Um, yeah, but ultimately, guys, I gotta tell you, you're not always going to find an instructor that matches the way that you learn, and sometimes you got to do it, right? So just take the class.
I had a tutor that speaking on to this subject, he told me his 103 teacher just played YouTube videos all the time and didn't really do much of the teaching.
Yeah, and again, ask around, ask each other, use the Discord, use any group chat you're in, use anything online, and decide, right? And so, oh, and Mehmet says, I wish 103 was taught in the summer. Yeah, that's actually when I would teach it. I taught it this past summer. Um, yeah,
103,
maybe,
you taught it in the summer?
huh?
You taught 103 in the summer?
Yeah, I taught it this past summer session one. So um, the links are still active for me.
Is it
Um,
gonna be, you said it wouldn't be offered in this summer though?
it is not. The,
Oh,
the, the offering depends on if the instructor is available, and that's not normally Dr. Moreno's schedule. So I don't think it'll be offered from Trade Tech, and I don't think it's offered from other schools. It's usually these higher science classes usually aren't offered in the summer or the winter, but I'm the reason I offer them is because I want to grow our program at Trade. So but no, so ask around, see what happens. If you take 103 in the next like 2 or 3 semesters and you need any like tips, um, you can email me and I can try and give you my old material for Physics 103, including like my slide set, you know, the ones that like I write all over, things like that. So yeah, um, yeah, do that. And Bifar says, I tried the link yesterday, but no luck for adding. So the link works. The link is only for me to get your information. And as I mentioned, I will send a Zoom link based on the emails I get from this form late Monday. Okay. And so I hope to see some of you in the spring. If not, join us in the summer. It's a good time to take the class. It'll be same format that I follow in this class. So yeah. I think that's all the announcements I have for the spring 102 class. Okay, I think so. Before we start on the actual homework, um, I was hoping to get some feedback from you guys. I'm hoping you can tell me if you have had in your science classes, math classes, or whatever class, if you've had discussions in them where you were required to post something and respond to people,
yep.
did you, hold on, did you find them useful?
No.
Okay, I hear no, I hear yes, I hear no's, not often. Okay, and if you did not, um, no, everybody BS them. Okay,
I thought
yeah.
I was doing them because I had to get the point.
That's so funny because when funny story, like right before the pandemic hit, completely before, I was already going through training, like the state training to do online classes, and I literally finished all of, and it's like a year long, and I finished it all like three or 4 weeks before the pandemic hit and we shut down. So I felt like, oh, okay, I could do online. I just went through all this training. But gosh, during the training, they had me do so many stupid discussions and I hated it. I think I was like Randy, where I was just waiting for someone to like post something so I can respond and just get it over with, right?
A discussion, I feel like, is the equivalent of having an important life decision to make and making a Facebook post and then waiting on that to make the decision. Like you're at the grocery store, you need to buy chicken or beef, and you decide to make a Facebook post about it. Like who's going to really wait until someone responds to that post to answer your question? Like I have homework that's due tomorrow. I can't wait until tonight when somebody else's schedule fits it to post.
So what I'm hearing from you, Randy, and from several people in the chat is that it doesn't feel genuine and it doesn't feel like you're gaining anything from it.
Yeah.
And I agree. And I shouldn't be recording this, but yeah, I agree and I feel the same. So I was I'm not adding this to any of my physics courses. I was thinking about it for another class, but I just kept thinking like, I don't even know how to grade that. Like, how do I, I can say, put a meaningful response. Like what's, I can't grade. I don't know. Then I realize it's just like busy work, right? Then I'm just like grading because you did it. And so, okay, so no one liked it. Yeah, exactly. So I wonder, okay, follow-up question, and then I promise we'll start. Is there anything that you liked in any of your classes, preferably a science or math class, that was not homework, that was not a presentation, that is not lab?
Oh, I have one.
Okay.
I really liked so my math teacher had like drop-in office hours. I love that. That was the only way I got through the course. It was like,
How is that different from regular office hours?
well, you don't have to make an appointment first. Like you need help, you're doing your homework during that time. You go into the meeting, that's always the same meeting. You just enter it and then you go, "Oh, hey." And there's other students in there, sometimes, and they're just going back and forth and asking the questions. It's
Uh-huh.
not private, like it's perfect. It's like because I hate tutoring because you have to make an appointment because sometimes they're not available. So you have to like plan the time. Well, I just do it when I have the time.
So okay, when I hear drop in office hours, I kind of what I've thought of is like just like a study session, like an open study session type thing where
Yeah,
people
yeah. It's
just
like
log.
my teacher is there whether I'm there or not, and so like whether other students are there or not, you kind of like can drop in. Sometimes they have the same question. Sometimes they're not even so he has them for different classes all at the same time. So sometimes I
Yeah.
have to like listen to an algebra thing, but it's fine.
So that's and that's in addition to regular office hours.
Um, I don't know if that's in addition to regular office hours. I think like maybe he would meet you if he could during like a certain time, but like he had these scheduled office hours. He did every like he had them pretty much all the days of the week. He didn't wasn't really available on weekends, but sometimes if you needed him, he would like meet with you on a weekend.
Mm. So okay, thank you for that one. I will add that to my potential list. Um, Anyone else? Anyone have anything else that was not a lab, not a homework, not a presentation that they liked? Okay. So I see Daniela likes the big whiteboard feature that you guys can share. Man, I love field trips, but I love field trips so much. um, yeah, that one's hard. It's hard just because I can't. I, you know, I can't ask you guys to go places.
Well, I had this crazy lady that made me watch the squirrel video, and I enjoyed it thoroughly.
Crazy. I love the squirrel videos so much. Okay. And Owen, I like when classes interact, work out problems together. Oh, okay. Um, hmm. Okay. I'm thinking of ways to combine this. And again, this isn't going to change anything for Physics 102 if you're taking it with me. I'm actually thinking for my engineering class that only meets once a week because that once a week stuff just kind of drives me nuts. Like we planned that for on campus, not off campus. So now it's like I'm stuck with like trying to talk for like 3 or 4 hours and I can't do that. Yes, it's a 4 hour meeting and I can't. And I'm not willing to like mess with my mental health over it and leave class with a bad headache. Yeah. That's
Even
that's
in
yeah.
even in
Oh,
person, the teachers usually let you out early. Like they let you out 2 hours early.
yeah.
It's a
Yeah.
3 hour class only once a week. You can't do that.
Yeah, you're totally right. Okay, on the seminar was fun. That's what that class turns into, a seminar, but they give the seminar. But it would be really cool to incorporate going to like fun seminars. And I see so many, like every week I see several. So yeah, that's a good one too. Um, Videos embedded with questions for chemistry. The professor didn't format it the best, but I think it'd be potentially useful. That's a great one too, Isla. Let me you know what, my let me show you guys a video just for the exam for anyone out there that is curious about the solution. um, I have to like resync all of my OneDrives because something happened and they're not syncing with each other anymore. But give me a second and I'm gonna pull up this video for you guys. Yeah, I like the seminar ideas. I like the whiteboard and working things out together and having like I thought of having like a study session, like a Friday night type thing, because I don't now do anything on Friday nights, but the timing of it all is the hard part. So I'll think some more, but I really appreciate all of your opinions because
With
if
the
this is gonna, huh?
with the timing thing, like some teachers they do this like poll or something on Zoom, that lets so that they can pick the hours that are most available to most people.
Yeah, that's a poll for, yeah, it's what I'm more concerned about is like, so on the backside of what you guys see, some instructors are spending like, my average day can be up to 12 to 14 hours. And so for me to sit again here for another 2 hours, I don't know if I could keep my patience. You know, like, I don't know if I could keep my patience. I don't, and I certainly don't want to take it out on you guys at all. So I gotta figure that out. I definitely do gotta figure that out. Okay, let me find this quick thing I wanted to show you guys, and then I promise we'll start the homework.
Like when you say in addition to office hours, like do you so during the time that he was doing that, he was usually grading stuff. Like so I think maybe that was his regular office hours. Like say, is that what you guys do when you have like office hours in school? You sit there and grade and stuff?
I sit there and do other work, yeah, but on Zoom things are just different. I can't focus when I'm on Zoom with you guys. I'm on Zoom with you guys.
Yeah.
I can't, like, even during the exam, I'm trying to do other work, but it's really hard for me to do other work. So it's very personal, like how you do it. But I'm totally, you know, willing to like think about it and see what I can do. Okay, I cannot find this file quickly, unfortunately, and I don't think I want to waste any more time on it. But it's a cool video. Dang it. Um, reasons I hate the internet sometimes. Inertia. Oh, wait. Let me try that. Okay. 1 second, guys. I'm going to find it. I'm going to find it.
I bet if it was selling you a product, it'd find you.
Yeah. You're totally right. Wow, this is just all messed up. Ugh. It's okay, maybe here. I don't even know what I'm looking for. Let me just stop. Yeah, it's not there, but I really wanted to show you guys a cool video. Oh, you know what? I can Google it. I can Google it. Just, you know. Uh, I'm pretty sure I'll find it quicker this way. Okay, I just give up. I'm sorry, guys. I wish I could get this video for you guys quickly, but my folders aren't syncing and it's on another laptop, so dang. It was the solution to the question on the exam.
Which one?
The ramp.
Oh, that a version of that was kind of in that like that videos that you put on that are what's it called?
Crash
The
course.
girl crash course. Yeah, that's.
Yeah, that's right. Okay,
And it's completely opposite of what I would assume.
isn't that interesting? I also think the same. I don't. It is opposite of what you would assume. So I'm so surprised I can't find this video, but um, I just really want to show it to you guys. I'm gonna just bring the laptop and airdrop it. That'll be really fast. 1 second.
Oh yeah. AirDrop is definitely the most useful feature in the world.
You guys can see all the wrong answers on Chegg again. You see. Anyways, okay, so let me airdrop this video to myself, and then we can talk about that answer for the exam, and we can also talk about the homework. Did anyone have any issues with any specific problem on the homework?
Um,
That's all we're doing today. I think you guys should stick around, but that is all we're doing today.
I don't think I had like particular issues, but the numbers seemed weird to me.
Oh, okay.
Um, that would be on number, the ones that you had, the 4 and 5.
Mhm.
Like I got 58 Newton meters for number 5, and that seemed really high,
Okay.
even though the
So
mass
I
for the planet was, I think, a little smaller than Earth, right?
Yeah. So that'll be something that you guys can talk about amongst each other, like the actual solution, and I will guide you through how to do it. The numbers and all that, that part you guys can kind of work out, but we can certainly talk about does it make sense, right? So I found the video. Thank you everyone for waiting. I know I'm usually much more prepared than this, but I just really wanted to show this video. Okay, so you guys had your guesses on the exam, right? Like what mathematically it was, and this is also very opposite to what you would think, like your intuition. But this really shows us that angular rotation acts in a certain way specific to these mathematical relationships. Okay, here's the video. I'll rewind it so you guys can see.
So like if our cars had tires that were circular, we'd be doing better.
If our cars had tires
That were spherical, I mean.
that were spherical, if you're going downhill, yeah. If you're going downhill, yeah.
They'd be more efficient. Well, I guess they wouldn't be more efficient if you were trying to stop.
Yeah. Yeah, and so here's your answer. A lot of you guys could, yes, it completely has to do with the inertia and the center of mass equation. So this is your answer. This one, the solid sphere goes down first, then you have your solid cylinder, then you have your hollow sphere, and then you have your ring. Oh, I see all of you guys. Yeah, you got it. But this was actually, I found this video on Reddit, on like a physics discussion board on Reddit, and um, I had to calculate just to make sure that it was correct, because you can't always trust the internet, and it was correct, and I thought it was the coolest video ever. So yeah, good job guys if you got it. But you also had to have the supportive information, right? Yeah. Yeah, good physics all over the internet.
What gets
Okay,
me is a box with no roundness at all would make it down faster than any of them.
a box with no roundness would make
Yeah,
it faster. Wow.
like that was on the crash course video. I was like, what? No way. The flat box, scraping all the way down. But it's
Yeah,
like a frictionless situation. So
yeah. I totally hear you. Um, it's really funny how we think certain things because of other situations, and then as soon as you apply the actual physics to it, you see that it's a little bit different, right?
counterintuitive.
Um, okay, so I'm going to take us to Canvas, and I think,
Do you think it's because we always see wheels turning and we think, oh, cars go fast?
yeah, that could very much be it. Yeah, I'm gonna just close some things so that I could make sure that this um, doesn't go crazy on me. And I'll just leave this screen open. Also, let me know if it's not sharing right now, but just let me know if it's big enough for you guys to see it. I'm gonna open it. It's probably just easier if I show the PDF instead. I'll do that. Okay, and let me open up my notes for this. So this was actually a quiz, in an in-class quiz for previous classes. And for you guys, it's your homework, which I think, again, you should really take the time to try to solve the answers on your own and see how you do. Okay.
Oh, that's another thing. So like one of my math classes had like it was an accelerated course over the summer.
Uh-huh.
So, but she had like for every like chapter or lesson or whatever, you'd have like a quiz with maybe only 2 questions on it, you know, and you could take that 3 times, and that was like part of your grade too, because those quiz questions helped you like gear what was going to be on the test. You know, the quiz were very comparable to the tests.
I really like those quizzes, but how do you guys find them useful? And I
Uh-huh.
really want to hear honesty here because I I see those quiz questions on Chegg also, and so then I just want to do what's actually useful. Okay, you like them for points, but
I
homework.
thought they were useful because they helped me know you know, like homework sometimes is more challenging than the test, but if the teacher writes the quiz and the teacher also writes the exam, that helps me like, you know, feel more prepared for the test.
Okay, okay, yeah, I'm kind of on board with those. Yeah, especially for those of you who are truly like not using Chegg and learning through it. If it really helps, I love the conceptual questions. I'm all about it too. All right, thanks guys. That's really really helpful. Okay. Yeah, you guys gave me some great ideas today. My materials of engineering class will thank you later. And then we'll see, maybe physics 102 in the summer, you might see some of these things in there too. Oh yeah, for cementing technique. Okay, yeah. Anything that just keeps supporting your your solutions, right? Anything that supports your thought process. I'm with it. Um, is the screen okay at an okay size? We're not going to write too much, but I just want to make sure you guys can actually. Okay, I see some thumbs up. Thanks, guys. So let's go through the questions kind of one by one. And again, I'm not solving them at all. If you guys want to solve them by talking in the chat or just unmuting, that's totally okay with me. But we're going to kind of start with what equations do we need for each question, right? So we can start with this first one. Let me see if I have my little, does
So
this,
we're supposed to have numbers written down.
no,
Oh, okay, okay.
if you don't have numbers, you can't write numbers. Yeah, if there's no numbers, it's okay. I think only the ones on the next page have some numbers. So let's start here. Um, Two identical objects are released from rest from heights r and 2r above the surface of the Earth. After traveling a distance r over 2, which object has the larger energy?
So I'd say delta E equals K plus UG.
Yeah, that's exactly how you want to solve this. So thank you, Randy. You want to solve this by looking at the total energy, right? The total energy and knowing that it's conserved. And so here, this is the mechanical energy because we're not looking at the internal processes. And you want to remember here that your mechanical energy um, is what Randy just said, kinetic plus potential, right? Ke plus Pe. Now, when it comes to, and this is very similar to the other problems we answered yesterday about like the the aphelion and the perihelion, right? The only thing that might be kind of hard here is figuring out these R's and 2R's, right? So I'll first show you just what the heights are, R and 2R. So you can say that from here to here to point A is R, and then from there all the way to point B is 2R. But the distance that each is going to travel, I should probably put Y because it's a height and we normally think of height vertically, but this is horizontally, right? It got moved. So we'll use X. The height that each travels is R over 2. So this is going to move some distance R over 2. And I'm going to try very hard to keep the arrow the same size. This is going to travel some distance R over 2. And now you can go ahead and compare using these. And again, I'm not going to give you solutions here, but I'm happy to hear solutions if anyone has overwhelming response here to help out the whole class.
So I'd say the object that was furthest away, but then I question that because I wonder, are you looking for us to calculate how the further one away their gravity gets less as they get further away from Earth? Or no, that's too in depth.
That's too in depth.
Okay.
Yeah.
So then
So
it's the furthest away one.
Okay, so I hear Randy, I see some head nodding, and I see Owen and Bafar saying, yeah, that let's go with this one. So I'm hearing from you guys that this might be the answer. So that's a good way to start. But this is how you would solve this problem, is using this change in mechanical energy. Okay, so I see several responses in the chat. That's good. Um, Okay, so again, no numbers here. Let's move on to the next one. A planet has the orbit shown below. Use the 8 labeled points to answer the question. At what position is the planet when the total energy of the system is largest? So we did something similar to this in class, but before we answer the question, or all the answers before before we answer the question, which is okay if you want to put responses in the chat, totally fine. Um, Let me just make sure you know what this image is telling us here, right? The first thing is that we have an elliptical orbit, and we have the focus. The sun is at one focus, and then nothing is at the other focus. I'm going to try and draw it exactly where it should be. Nothing is at the other focus. And so these are different positions along the path here. So at what position is the planet when the total energy of the system is largest? And so this total energy, again, you want to use, and we actually did this in class yesterday, equals kinetic energy plus potential energy again. And think about, okay, I see several people. Oh, I thought the sun was orbiting. No wonder I was getting thrown off so bad. Yeah, and these sometimes you gotta first figure out what these images are, right? This is the sun at one focus, and this is nothing at focus 2. And so just remember that as you're traveling from, I wonder if I can change colors here. As you're traveling from here to here to position 3 to position 4, you want to think about what changes. Your radius is going to change, and then it's going to finally have a maximum and then decrease again and again and again. So as the radius goes up, what happens to, let's say, the speed, right? And think about it the other way around too. As the radius goes down, what happens to the speed, and how does that apply to the total energy of the system? Okay, so I see several, well, just a few answers, because delta E is conserved. Yeah, and conservation of energy takes you a far way here. So that's great. So we can take kind of the same concepts here and go to number 3 now. A planet has the orbit shown below, and use the 8 labeled points to answer the question. At which point is the x component of the velocity the largest? So the x component, right? Oh yeah. Randy has a good supporting evidence for his answer for number 2. Okay, actually, I should add to that what Randy says, right? When the kinetic energy is high, the potential energy is low. And then when the potential energy is high, the kinetic energy is low. And so this goes along. That's good. Okay, let's try number 3. Now we're looking for the x component of velocity. So just let me remind you, the x component is this, right? And when you're looking at this, they are not asking for the total velocity, which is made up of x and y. So you need to really focus on the x component, right? Okay, so here, let me just show you what the y component of velocity would look like at its largest. At its largest, it would be an arrow straight up. The velocity in x at its largest would have the largest magnitude either horizontally in some way, right? And so you want to find, let's say, a point here, the velocity's component is all in one direction. So here, the total velocity is made up of just the y component, right? Ah, okay, I see lots of talk about 5, right? And so what is happening at 5? You guys tell me. Oh, when okay, I'm not sure, but I'm going to keep going. So just go around and draw what the velocity would look like, right? So the total velocity here, would be maybe drawn like this, tangent to the orbit, right? Tangent back to the orbit. And so here you want to look at your velocity and see that it's going to have some y component here and some x component here. And then at point 3, your velocity is completely in one way there. And so the total velocity here is equal to just the velocity in x. So going around, figure out where your magnitude and your arrow is going to be the largest. Yeah. Okay. I see you guys kind of thinking about this some more, and that's what you want to do. Think about it a little bit more. I probably should have drawn that straighter just so that no one gets lost here.
When you mean largest, do you mean like largest magnitude or largest positive?
Largest magnitude is the best way to say it, but I guess if you're moving, I guess if we're I would say largest magnitude, but I'm not really sure. Hold on, sorry. Um, there's so many things to draw here. I'm not really sure, like specifically what they would mean. Um, they don't specify magnitude, so perhaps positive, perhaps the positive value, which would be speeding up, right? And then oh, you know what though? You're not given information about how it's turning. So it's absolutely the magnitude. It's absolutely the magnitude because you don't know if it's speeding up or speeding down and speeding up or decreasing magnitude. So that's a good point. And by reading the question, you see that they don't give us enough information of how it's moving, right? I'm assuming that the planet or the object is moving counterclockwise, but that's just my assumption, right? So they don't give it to us. So maybe magnitude, and if it's magnitude, then you should get 2 points. Is that right? Maybe we'll get 2 points. Yeah. So go around and draw the velocity vector and see where its x component is the same. When you draw this velocity vector, it might be hard to think about. I would just assign it a random direction, and know that the opposite will be true too. But you really are looking for this x component. So I think Noah and Owen, you guys are on the right track here, where you're going to have the largest x component. Yeah.
So what does the x component look like? Oh, so at 1 and 5, it has no x component.
That's correct. Here, the total velocity is tangent to this line, right? Like it is at any point, but tangent to the line here is only in the vertical. Yeah. So I'll let you guys think of the rest. I'm gonna scroll up, but I think it's not gonna let me keep my annotation. So the recording will be available, but you could also screenshot if you like. Oh, Owen says, how would it change if there were 2 bodies? By 2 bodies, you mean 2 moving bodies? Two moving objects? 2 centers of gravity. Okay, that's what I was clarifying. And when you say centers of gravity, I think what you're referring to is 2 foci, like the sun and something else, and it's orbiting around that. I think it would depend on the mass of each. The one with the greater mass is the one that will dominate in gravitation. Yeah, that'll for sure be true. So the shape would depend on that. If they're equal, I think it would be like maybe an infinity sign. I don't know. It's not going to just be an elliptical because it's going to pull equally in each way. So maybe it would be like an infinity sign. Yeah, definitely depends on how far apart they are too. And how far apart is going to make it either really thin or really, really wide, right? We don't use the F word, fat. Okay. Any comments or questions here for 1, 2, or 3 before I move on to the next one? Okay, I'm gonna attempt to erase the entire board. Huh, It'll work. All right. I'm not a fan of the annotate feature because it makes me see I can't scroll. I can't scroll. That's stupid. Okay, let's try these now. So number 4,
You mean you can't
the
with your
period.
computer? When you're annotating,
What?
I think when you're annotating, you can scroll your computer as long as you have to use 2 fingers though.
I have a mouse.
Oh.
But thank you, Randy. When I use my mouse trackpad thing, I'll do that. Let's try it. That's something I should try. Oh no, it's not working. It only works when I get off of the shared screen. As soon as I'm off of the shared screen, it works. Okay, number 4. The period of a satellite circling planet Neutron is observed to be 84 seconds when it is in a circular orbit with a radius of 8 times 10 to the 6th meters. What is the mass of planet Neutron? Okay, so here we just want to start with writing out everything we're given, right? So the period is 84 seconds. That's what they said, right? Yeah, the period. Okay. And when it is in a circular orbit with a radius of this, so it's orbiting with some radius, that number there, 8 times 10 to the 6th. Okay. What is the mass of planet Neutron? So this is, what is the mass of planet Neutron? So any ideas how to find this mass? We did a similar problem. Okay, we have some ideas from Randy, and that is probably the go-to because we did we did that so many times in class, right? The solving for the Newton's second law using gravitational motion, right? So what Randy is saying is Fg equals mac a sub c, and you also have at your fingertips Fg is equal to this constant, mass 1, mass 2. So you have all of this. Now, you can go this route and eventually solve for this velocity and radius thing. But the thing I'll remind you of, and the way to go here, is to use Kepler's third law, right? Kepler's third law is the one that helped us figure out what is the mass of the sun. So we actually did a problem just like this. And so Kepler's third law tells us that the period squared is equal to 4 pi squared over the gravitational constant times the mass of the planet. We'll call it planet Neutron. Who is calling me? We don't care. Times r cubed. And so this is much more direct, but all of this does come, this is all derived from this, right? Kepler's third law is derived from this. So your direct route here is to just go to Kepler's third law and solve with that. And notice here, Jimmy Neutron. Do you guys ever find that I run into people sometimes and they either always look like Jimmy Neutron or Olaf from Frozen? Um, I don't know.
Third teacher, Mrs. Fowl.
I'm not saying it's a bad thing. I'm just
you know, every time they talk, that would be bad.
I'm just saying when people have like really big like smiles, really big goofy smiles, they kind of look like Olaf. Oh no, I hope, dang it, I forgot to charge the mouse last night. Okay, so we have the period, right? We have the radius, and so here very nicely you can solve for this. Isn't that nice? This problem's pretty cool. Yeah.
So we have the radius of, now see, here's where I get confused. We have the radius of the whatchamacallit, of the satellite, but we don't have the radius of the planet.
You have the radius of the circular orbit.
Okay.
So here's the planet. Here is, what is it? A satellite, neutron. And you have the radius of this orbit.
And so like this, so what if we were trying to solve for the mass of the satellite? Would this, like, that's where I get confused, like the numbers and, you know, like.
So the mass of the satellite is what we're solving for, or I'm sorry, planet neutron. Oh, did I mix up the things? The period of the satellite circling neutron. No, I didn't mix them up. Okay. This is the mass of planet neutron. That's what we're solving for. Oh, so you're asking what if we were solving for the mass of the satellite? The mass of the satellite is here.
Yeah.
So the thing that is exerting the force is the planet. So this would be the planet. And the thing that is being acted on is the second mass. So here, the second mass would be the satellite, and this would be the satellite. And this is why the mass of the satellites cancel out when you equate them to each other.
So that first one is the thing exerting the force.
Yeah, M1 exerts a force onto M2. The planet neutron exerts a gravitational force onto the satellite. And then the force of gravity is exerted onto the satellite and holds it in a centripetal orbit. And then I have a question in the chat that says, in the slides, instead of r cubed, it says a cubed for the formula. Is that the same thing? Yeah, so in the formula here, we use r cubed whenever you have a circular model. If you wanted to use this model for an ellipse, this would be the same as using A. A is the semi-major axis. So if you were using like an elliptical orbit, you could use A. Usually it specifies circular. Yeah, and the circular model we see works really generally well because the ellipses are are very low. The eccentricity is low. Oh, and yes, I did do this in my astronomy class, and this is why I added that note in the slides that r cubed is like a cubed. Um, this is also, had we done this in class, we would have done a lab where we actually calculated that this was true for a real NASA satellite that's orbiting us right now. But um, it really depends on how you graph things. So if you're graphing things online using Desmos or even Excel, the grid is never equal. It's not always a square, and so it throws off your whole image. And if we do it online, it throws everyone's math off. So yeah, it's okay.
So like,
Um,
can we
so
come back to that, like that the M1 is the thing exerting the force? So
yeah,
like
sure.
what if I were to like what if I were to have that, so like M, so the first one is M, the neutron, right? And the second one
Yeah,
is,
you went out for a second.
and then the second one is the satellite. So say if I got that confused, like say if I mixed that up on a problem similar to this, like would I get the right answers or no? I'd get the wrong answers.
You'd get the wrong answers because your masses wouldn't cancel each other out. When you equate this force of gravity to this force of gravity, the mass of the satellites cancel each other out. If you were to invert them twice, like you wrote planet here and wrote planet here, then like if you made that mistake twice, then your answer would coincidentally work out. But no, if you happen to swap the order of these, you or the order of this one, it wouldn't cancel out. The main one you want to get right is this one, right? Because as long as you know that the force of gravity is being applied to the satellite to keep it in the centripetal orbit, this will cancel out with this any of the m's, whichever way you write it here. So this is really the one you want to get right. But the proper order is the mass, the force that object one exerts onto object two.
Okay.
And let me just answer Nate's question. Should we just study chapter 13 for the final test? In the syllabus, it says 13, 14, and 15 for the test Thursday. So it's only chapter 13. And Nate, if you're asking that question, I feel it's my responsibility to tell you that our final test on Thursday is an online quiz on Canvas that will be available after today's class. And you will have until tomorrow to finish it, but only one opportunity and about 25 minutes or 25 minutes to answer 5 questions.
That seems like a nice test.
I think it's nice. I like it.
I like your format for this class, especially because like the last week doesn't make you want to blow your brains out. It like kind of makes you feel like, oh, life's gonna be okay.
Life is going to be okay. That's right.
Like
Yeah.
my math class in the fall, I had a 50-page review over the weekend between the last class and the final. Like I sat in bed for like 10 hours a day doing this thing.
Mhm. Yeah. You no, don't blow your brains out. Don't do anything like that. For my, I'll just tell you guys quickly. For in my PhD program, at the end of the first year, you have a written qualifying exam, and it's mine was based on, it was 5 hours based on 5 classes that I took, all in 5 subjects, right? And one of the teachers, his subject was crystal structure, and he told us that he was going to put any crystal structure that is needed, right? And so there are over 220 crystal structures. And so someone asked him, like, you know, we have to know all of them. And he was like, yes, you're a scientist. You have to know them all. And so, so everyone made like 220 flashcards and was memorizing all of the crystal structures. And again, guys, um, everyone else was much, much younger than me. I was older because I took a much longer route to get to my PhD, which I also didn't tell you guys about the many struggles along the path. It was not smooth sailing by any means. There were several jobs that I had to work, several times that I was on academic probation, all of that. I forgot to tell you guys about the struggles, but I was like older in these, and I was over people trying to like threaten me or tell me you got to know it all. Like, I know I don't have to know it all. Like, I know. And so everyone memorized all 220 crystal structures. I memorized 10. I went to the list and I took the first 10. And what was on the question, on the exam? The first 10. So I was like, what are you guys doing? Like, it just doesn't make sense, like to memorize 220. Like, what the hell? Oh, I'm many days over 20. Saja.
But what if you would have got onto that test and you needed to know the last 10?
That's a great question, Randy. I would not have let myself fail. I would have made up a crystal structure or used any single one and just did the process. The worst he can say is, "Oh, that's the wrong crystal structure," but the rest of your process was correct. Yeah, you're totally right. What if, right? It was a gamble, but it's just unrealistic to tell us to memorize 220. Like, anyways. I was like, what the hell?
Good for you. I like your attitude.
I was over it. Like, everyone else was just, yeah, everyone else was like 22, 23, 24, and I was not. So I was like, I'm not doing this. 220 plus. There's like 224, 227 crystal structures. I was like, no, I'm not doing this. Yeah.
What?
Yeah. Yeah. It's pretty cool. It's actually really, really cool, but no. Okay. Let me see. Oh, a quick question. How will spring differ for winter and how the class runs? It runs exactly the same. I'm the same person from winter to spring. So it'll run exactly the same structure, same syllabus. The only thing that changes is the timing. So maybe you'll have one chapter per week, sometimes 2 chapters when we're in thermal. You might also have one extra assignment. Yeah. This winter, we missed, I think we missed one lab and a few reports. That was all we missed. Yeah. Isla, 22 to 24-year-olds were getting PhDs. Yeah, when for this program, a lot of people, because it was very new, a lot of the people in my PhD program were coming from UCR and staying at UCR. So they were mentored from their through their undergraduate degree, and really, kind of prepped like 3 to 4 years in the same lab as an undergrad to continue in the PhD. So they were starting they were just graduating with their bachelors, like 22, 23-year-olds, and here I am talking about like my 10-year high school reunion to these people. It was really funny. Yeah, yeah. You're not more perky in the spring? No. Well, maybe, I don't know. um yeah, I don't know. I might be. I don't know. Yeah, we'll see. You guys will find out. Okay, let's
Well,
try. Uh-huh.
hopefully you're more perky by summer then. I'll find out then.
If I'm not, I'll tell you this. I save all of my energy for class. All of my energy goes to class. And when I get out of class, I'm so impatient. I even tell my friends, can you talk faster? Like, can you just say it already? And I tell them I don't need a
Great class
transcript.
start.
Just Yeah, I tell my friends I don't need a transcript. Just tell me. Like, but out of class, I'm incredibly impatient. I use every bit of energy I have for class. So
We are honored.
yeah, yeah, it's good for you and I. So okay, let's do number 5. A 50-kilogram satellite circles planet Crouton every 5.6 hours in an orbit with a radius of 12 times 10 to the 6th meters. Yes, it is delicious, Owen. What is the magnitude of the gravitational force on the satellite by planet Crouton? So again, planet Crouton is the one that's providing the gravitational force. So we are solving for f of g. That's what we're solving for. Okay, that's what they want us to know. So let us work backwards as we've done in other problems. So the force of gravity is that gravitational constant, right? Times the mass of the thing exerting the force. Randy, what's exerting the force?
The planet.
That's right. Planet Crouton is exerting the force onto the mass of the satellite. And all of this is over r squared. So this is what we're solving for. Now let us look at what is it that we have here and what is it that we need. We know this gravitational constant. We're given the mass of the satellite. We know r squared, but we do not know the mass of planet Crouton. And look at what we did on this last problem. We calculated the mass of a planet using Kepler's third law. So let us
So
go.
see, on this problem, like back to the mixing them up, I think I mixed them up, but I mixed. So like what I had when I set my two things equal to each other was I had the mass of like the satellite
Uh-huh.
is equal. I had the mass of the or wait, I had the mass of the planet is equal to r omega is equal to the g times the mass of the satellite times the mass of the planet. So I mixed them out twice, and it just happened to work out, I think.
Yeah, when you mix them up twice, they cancel. So it works out. If you mix them up once, that's where that's where the problem comes in. But generally when we're talking about the force of gravity or Kepler's laws, which are something orbiting something else, you're talking about the mass of the planet, right? So notice that in Kepler's third law up here, I don't know if you guys can see this up here. um, this is the period is related to the radius of the planet that is providing the gravitational force. So when we write it again here, and again, I'll just remind you, this is Kepler's third law. um, this is again the period and the distance of some satellite or planet or moon that is gravitating around some larger planet that is providing that gravitational force. So the mass of the planet here is going to be the thing that we solve for. So we know the radius, we know pi, we know the number 4, we know the gravitational constant. And if you read carefully, we also know the period. Every 5.6 hours in an orbit. So that every 5.6 is the period. So you solve for this here, massive planet Crouton, and then you plug it in here. And then you can solve for the gravitational force exerted by planet Crouton onto the satellite. This is like the Big Bang Theory. Yeah, yeah. So a double mix-up will certainly cancel out. Um, mhm, mhm. Is this problem okay? This is probably the toughest of them, and I'll tell you that in class, when I've given a problem like this in class, about a little less than a third will miss this problem, and this is in class. So you're, you know, there's no phone usage and no internet, things like that. So a little less than a third will miss it because you don't know where this mass comes from, and you just got to recognize that this is the mass of a planet, and we can use Kepler's third law to figure out the mass of anything that's providing a gravitational force.
So in Kepler's law, that is the thing providing the force.
That's right. Yes. And again, Randy, if you forget, you go back to how it's derived, and how it's derived. It's this one is the mass providing the force. This is the mass that's orbiting, and this is the mass that's orbiting. So those masses that are orbiting cancel out because they're so small, right? Like the apple.
Yeah. That I have to say that helps a lot, because that was my main issue, getting those things straight.
Mhm.
Doing, because I kept thinking on the left side of the equation in terms of like the thing that was the centripetal force going inward, and so if it's the centripetal
Um,
of the satellite, then it must be the planet that's creating it. But
mhm.
instead, that logic would be used to apply to the right side of the equation, and make
Yeah.
a circular motion model on the left side.
Yeah, yeah. It's the follow through. So that's how you solve this problem. And your answer, the force should be in newtons, of course. And then you guys kind of see what you get. Let's do number 6. Which of the following quantities is conserved for a planet orbiting a star in a circular orbit? Only the planet itself is to be taken as the system. The star is not included. So you want to see which of these quantities is conserved. The first thing I would do is look at every quantity and write down the equations. Okay, and we see some possible answers in the chat. If anyone agrees or disagrees, okay, we got more answers. Fantastic. So this will help you for your homework. Now prove it to yourself, right? So we're looking at momentum, energy, angular momentum. Okay, we're looking at those three things. So
And momentum depends on velocity, and velocity is not constant.
okay, I hear it, right? Yeah, I hear it, and I see it also in the chat. Thank you, Randy. So the total energy would be the kinetic energy plus the potential energy, right? The momentum P is just regular momentum. That's mass times velocity, right? And angular momentum in these terms, MVR. And of course, it's also inertia times that angular speed, but we don't see anything. It's easier to keep them all in the same terms. So we're going to just write it all in linear terms. And so now you want to figure out which one of these remain conserved, right? So the change in E is equal to 0. Is that true here? And do that all the way down. Is the change in L equal to 0? Is the change in P equal to 0? Now it says here that the star is not included, and that's fine, but the planet is still orbiting something in a circle, right? This is the star, and we're orbiting in a perfect circle, some planet, and the system only includes the thing that is orbiting. So what is changing here is the velocity and the radius. Even though the star is not included, it is still moving in a circular orbit that has a radius. So you want to look at these and see which one remains conserved. Um, I'll tell you that kinetic energy has velocity and potential energy has radius. So those two will balance out. This has velocity and this has radius. So those two will balance out. But linear momentum might be a little bit different because only velocity is there. So what is there to balance out velocity for linear momentum?
Nada.
Say. Oh, Owen says the mass. The mass, yeah, that's true. But does the mass, will the mass balance out and change while we're orbiting? Will the mass balance, will the mass change? Correct. Owen says no. So yeah, take a look at this. So you have some answers in the chat too for what this one could be. Any questions on these three before we go to the last one? Okay, I see none, so I'm going to use that clear feature again. Screenshot anyone before I move on? Screenshot. Okay, I'm going to hit clear. Okay, it's in the recording too if you miss it. Okay, let's go to the last one. This is actually one of my favorite ones because it's you just, you use all the information they give you. The figure below shows a planet traveling in a counterclockwise direction on an elliptical path around a star located at one focus of the ellipse. When the planet is at point A, how is the speed changing? That's what it's asking. So here's the star at one focus, and at the other focus, we have nothing, right? This is focus 2. And it tells us that this planet A is orbiting counterclockwise. So counterclockwise is that way, right? Counterclockwise, and that's important to know. So as A is going, what's the question asking? Oh, when the planet is at point A, what is happening to its speed? So you guys tell me. You will have a specific radius here, and we want to know what's happening to its speed v, right? You want to make a judgment based on what's happening when it's somewhere else, right? You know it's moving counterclockwise, so you know that the radius is going to reduce as it continues to move clockwise. So if the radius is reducing, then something must happen to the speed. Yeah, so I think Randy gives us the response there. So this is a good answer, a good question because of the details in the question, right? How do you answer this? And if you forget where this comes from, you remember that the change in angular momentum must equal 0. And this angular momentum, L, is equal to mvr. And so the mass remains constant, and so L is proportional to the velocity and the radius. So as the planet is at point A, it is reducing its radius from its largest point, which was right here. So as the radius goes down, what has to happen to the velocity to maintain, angular momentum being conserved? Yeah, the velocity then will go up. So you can choose here. Voila. That's all I got.
Can I have a question? Can I ask a question on the lab?
Yeah. Oh yeah. Hold on, Randy. Yes, you totally can, but just give me a second. Any other questions about this problem or this homework? Are we okay there? Okay, so I'm gonna clear this and I'm going to stop sharing, and that's all I have for you guys today. So I'll remind you that actually I'll just show you on Canvas really quickly where your quiz is going to show up and the several places that you can find it. I think I have it set up to open at 12:30 today. So you'll see it at 12:30, and you will see it in 2 places on Canvas. This is on the screen right now. So on Canvas, you can click on quizzes on the right here, Is that the right? No, that's the left, right? You can click on quizzes on the left. Yeah, on the left. Or at 12:30, if you refresh your Canvas, the quiz will appear down here somewhere. It'll appear on this module also. So either way, you can find the quiz. Let me emphasize again, if you have the chance to take it on a computer, take it on a computer. You want to make sure you use an updated internet browser because there are pictures and there's only one way the pictures will appear, and if you're on the right internet browser. If you don't see the pictures and you need a picture, I recommend you logging out of the quiz and changing browsers. Like Chrome should work. I think Firefox works or Mozilla works, maybe not Internet Explorer. I don't know. And then on the phone, it'll be harder to see too. So take a moment if you can to do it on a computer screen. Okay. I am all done, so I am going to stop recording and let you guys go on, do your thing. But before you all leave, if I don't see you, don't leave just yet. Give me 2 seconds and then we'll move on to questions. If I don't see you in Physics 102 or in any other future class, I want you guys to know that here forever on out, I am absolutely a resource for whatever you need. So you can email me if you need something in the future. Anything at all, anything at all. I'm a resource for you. So if you find yourself saying, I don't know what to do and I don't know which way to go about it, you can email me and I can help you even if you're not in my classes. It's okay. If it takes me a while to respond, just give me a friendly reminder a few days later and I'll get back to you. Yeah, I think that's all. I just want you to know you have a resource out there. So that is it. I really hope to see some of you on Monday or Tuesday, and if not, I'll see some of you maybe in the summer or in a future class or future presentation of some sort. Yeah, we're all done, guys. I'm gonna stop recording. Bye, Mehmet. I'll see you. Yeah, Summer, be there. Yeah, bye, guys. Thank you all. Thank you, Luis. Bye, Nathan. Bye, Amir. Bye, Isla. Bye, everyone. Bye, Bradley, Luis, Owen. Bye, Keon. I'll see you guys all very soon.
Yeah,
Bye.
see you on Tuesday. Thank you, Professor.
Okay, see you, Keon. Bye, Esmeralda. Bye, Saja. Bye, Alexandra. Bye, Sanjita. See you guys all. Bye, Daniela. I'll see you guys all soon, I hope. Yeah. Okay, I'm going to stop recording, and then Randy, you're up first with your lab question, and that's it.